Hi, Chelsea. How are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So, did you enjoy the snowfall today?
Yeah, it was nice to see. Cold,
Well,
but nice. Yeah.
that's good. It feels like winter is here now, right? Correct. So, in maths, what are you doing?
So today I wanted to go over double angle formulas and then also proving identities for
We'll do
trigonometry.
both the things. So, if you have some questions, we can share. Otherwise, I can share with my questions with you.
Okay, so I do have some questions, so
We
I'll
can
share.
begin from there.
Okay, sounds good.
Okay, let me annotate. Double angle formula. Sine 2 theta equals to 2 sine theta cos theta. Tan 2 theta is 2 tan theta minus 1 minus tan square theta. Cos 2 theta is 2 cos square theta minus 1, 1 minus 2 sine square theta, and cos square theta minus sine square theta. Do you remember these formulae?
Luckily for our test, it's not needed for memorization. She's giving us a formula sheet.
Okay,
So yeah.
very good. So we'll begin from here. Last time in our class, we did see how to derive these formulas. So we know actually how to derive from sum and sum and compound angle formula, correct?
Yeah.
So can you reduce your screen so I'll get more writing space on the sides?
Uh,
That is good. That is good. So I can see. So basically, we know that sine of A plus B, you can write alpha and beta also, is equal to sine A cos B plus cos A sine B, correct?
yeah.
So to get double angle formulae, what we do is we write A equals to B equals to theta. Simple as that. So we get sine of theta plus theta equals to sine theta cos theta plus cos theta sine theta, right?
Mhm.
And that gives you sine of 2 theta equals to 2 times sine theta cos theta. So it doesn't really take much time. Similarly, you can write cos of A plus B equals to cos A cos B minus sine A sine B. Now, substituting A equals to B equals to theta, we could write this as cos of theta plus theta equals to cos theta minus sine theta, correct? And
Mhm.
you do get, as written in your formula sheet, cos square theta minus sine square theta. Now you can do two substitution to get the other two formulae, which is cos square theta equals to 1 minus sine square theta. And the second one is sine square theta equals to 1 minus cos square theta. If you do these substitution, substituting cos square theta by 1 minus sine square theta, you will get what? You will get cos 2 theta equals to 1 minus 2 sine square theta. And if you replace sine square theta with 1 minus cos square theta, in that case, cos 2 theta will be 2 cos square theta plus 1. Is that okay? 2 cos square theta minus 1, right? So that is what, so not minus 1. Is that clear to you? So we get both the formula here, all the three of them as shown. So it's good you are getting the sheets, but sometimes that could be your question to derive the formula itself. It's an identity. Is that clear to you?
Yeah. Could you explain one more time, sir, the cos squared theta
Okay.
and deriving it?
Okay. So let me rewrite this. We did get that cos 2 theta equals to cos square theta minus sine square theta, correct? So if I write sine square theta as 1 minus cos square theta, because you know the Pythagorean identity, you remember that? So which
Yeah.
is cos square theta plus sine square theta equals to 1. So that's the Pythagorean identity. So you can use that Pythagorean identity, replace sine square theta with 1 minus cos square theta. And if you do that, what do you get? You get cos 2 theta equals to cos square theta minus, within brackets, 1 minus cos square theta. If you open the bracket, you get cos square theta minus 1 plus cos square theta. That gives you 2 cos square theta minus 1, which is the first formula written here. Is that clear to you?
So you use a Pythagorean formula.
Yes, trigonometric and to get the other two varieties. Now,
Mhm.
cos 2 theta is extremely important formula set because it helps you to write cosine in terms of sine also, correct? I could
Mhm.
write cos 2 theta as 1 minus 2 sine square theta. So if in an equation I have got sine square theta, I could write it in terms of cos 2 theta. You get the idea.
Yeah.
So it
So
really helps. Yeah.
so cos 2 theta could be like any of those three
Yeah.
equations.
So yeah, you could mark them as 1, 2, 3 equations. Any of these three can be used. Perfect. So keep this in mind while we work with these equations. Is that clear?
Yeah.
Now let's begin with the very first question, which is what? If, can you please read this?
Yes. Example A, if cos theta equals -2/3 and theta is greater than or equal to 0 and less than or equal to 2 pi, determine the value of cos 2 theta and sine 2 theta.
Perfect. So you are given that cos theta is -2/3. So look at the coordinate plane and you remember the cos rule, right? Since cos 2 theta is negative, that means you expect your principal arm, either terminal arm, either in quadrant 3 or in quadrant 4. You get the idea.
Yeah.
So therefore, when you are saying that this is between 0 to 2 pi, you have to consider both the cases. So now we'll find the value of cos 2 theta and sine 2 theta in quadrant 3 and in quadrant 4. Is that clear to you?
Yeah.
Correct. So cos 2 theta basically is equal to what? Cos 2 theta is 2 cos square theta minus 1. We know one of the formulas, right? So we know what cos theta is. So we'll just multiply by 2 times -2/3 whole squared minus 1. What do you get? 2 times 4/9 minus 1, correct? Which is what? Which is 8/9. We can write like this, over 9, which is -1/9, correct?
Mhm.
So we either value will give you the same answer, which is -1/9. Is that clear to you?
Yeah.
Correct. So that becomes the answer for cos 2 theta. So we got cos 2 theta equals to -1/9. Now let's find what sine 2 theta is, right? For finding sine 2 theta, we have to find the value of, see, cos is negative in both the places, but it could be in either quadrant. So what could be sine theta? Tell me. Sine 2 theta, you know, is sine 2 theta is 2 sine theta cos theta. Correct? 2 sine theta cos theta. We know the value of cos theta, but we don't know what sine theta is. Is that okay?
Yeah.
So basically, if cos theta is -2/3, in that case, sine theta will be how much? You can actually make a triangle with cos theta as equal to, let me write down the values, 2 and 3, correct? So what is the opposite side equals to?
So you can use
Please.
Pythagorean theorem.
Yes, so 9 minus 4 is 5, so square root of 5. Does it make sense to you?
Yeah.
So in this quadrant, actually speaking, sine theta will be equal to positive square root 5/2, right? However, in quadrant 3, what did I write? I should have written 2 here and 3 here, right? Yeah. And this is 4 and this is 1. Okay. So in quadrant 3, it is going to be -5 square root over 2, correct? Because sine is negative in quadrant 3. So sine 2 theta will have two values. One, if you consider quadrant 2, in that case, sine 2 theta will be equals to 2 times sine theta, which is square root 5/3, correct? 5/3, right? 5/3. And cos theta is given to us as -2/3. Is that clear to you?
Yeah.
You can multiply and get the answer. Definitely. This is negative 2 times 2, 4, square root 5 over 9. Is that clear? But if you consider the quadrant 3, in that case, sine 2 theta will be equals to 2 times minus of square root 5 over 3 times minus of 2 over 3. So you get a positive value. Do you see that?
Yeah.
So these are two answers for sine 2 theta in this particular case. You get the idea?
Yeah. So because cos theta is negative, we know that it's quadrants 2 and 3. And
Yeah.
then when we go to find sine, we know that it also has to be negative.
If it happens to be in quadrant 2, sine will be positive. But in
Yeah.
quadrant 3, sine will be negative. So basically, what we did was we actually, from the given value of cos theta, which is equals to minus 2 over 3, means 2 and 3 this, minus because it is in quadrant 2 or in quadrant 3, correct? So from here, we found the other side as 3 square minus 2 square, which is 9 minus 4, which is square root of 5. So the value of sine theta could be square root of 5 over 3, hypotenuse 3, or it could be minus square root of 5 over 3, depending on which quadrant it is. And applying the formula of sine 2 theta, which is 2 sine theta cos theta is negative. But sine 2 theta, sine theta could be positive or negative. So if you are in quadrant 4, quadrant 2, you get a negative result because cos is negative. But when you are in quadrant 3, you get a positive result. So plus and minus 4 square root 5 over 9 becomes the sine value. Is it okay?
Mm-hmm.
So that is how we'll do it. So don't forget to consider both the quadrants, quadrant 2 and 3 in this particular case.
Okay.
Very, very critical. Otherwise, you lose straight away half the marks. Do you see that? It could be very expensive. Perfect?
Yeah.
Let's move on to the next question. I'll clear the screen now. Yes. Can you please read the question?
Yep. Example B, given tan theta equals negative 3 over 4, where 3 pi over 2, or sorry, where theta is greater than or equal to 3 pi over 2, or less than or equal to 2 pi, determine the value of cos 2 theta.
So first thing, you have to always see where you are. So you are between 2 pi and 3 pi by 2. So you are in quadrant 4, correct?
Yeah.
That is the value 2 pi. This is 3 pi by 2.
Yeah.
So in this, we know cos is positive. Is that okay? And tan is negative. So negative 3. So what you do is, from the given value, straight away, sketch your triangle first. Assume that the triangle is in quadrant 1, okay? Tan theta is 3 over 4, means the opposite side 3, this side 4, and you have theta angle. Is that clear to you? So that is a right angle triangle with hypotenuse as 5. 3 square plus 4 square square root. Perfect?
Yeah.
So we know our triangle. And that triangle gives you the value of sine and cosine, correct? So here you could write sine theta will be equal to minus 3 over 5. And cos theta will be equals to 4 over 5. Cos theta is positive in quadrant 4, correct? And we are using the given value of tan theta to get both the values. Clear?
Yeah.
The question is, find the value of cos 2 theta. So what is cos 2 theta equals to? You can use any of the known formulae, right? So you can say, well, let it be cos square theta minus sine square theta, for example, correct? So in that case, the cos value is 4 over 5 whole square minus sine value is 3 over 5 whole square, right? Minus of. When you square it, it becomes positive for sure. So 16 over 25 minus 9 over 25. So 25 is the common denominator. 16 minus 9. What do you get?
5 over 25.
7 over 25, right?
My bad.
So that becomes the answer, and this is how you're going to find the solution. Is that clear?
Mhm.
Okay, so let me clear this. Let's see the next question. Can you please read it?
Example C, use a double angle formula to find cos 15 degrees.
So how do you use double angle formula to find cos of 15 degrees? You have to write 15 as a combination of two whose angles are known to you, right? Because cos of A plus B is basically cos A cos B minus sin A sin B, correct? Now we are given cos of 15 degrees. How could I write 15? I could write 15 as a combination of 45 and 30, correct? 45 minus 30 degrees. So that becomes cos of 15 degrees, correct?
Yeah.
So I can now expand, and this is equals to cos A cos B plus sin A sin B, right?
Mhm.
And you know the exact values. Let's draw our triangles. 45 degrees, right? You know, you can write this as 1 square root 2, correct? Or I prefer to write, in this case, multiply each side by square root 2. I prefer to write square root 2, and 2, because then we don't have to rationalize. You get the idea. The other triangle, which is 30, 60, 90, is something like this. 1, 2, square root 3, correct? And that is 30 degrees, right? This, of course, is a right triangle. So from here, we get all the values, correct? We know cos of 45 is equal to sine of 45, correct? Both are same, which is square root 2 over 2, correct? And in this case, cos of 30 degrees is what? Square root 3 over 2. And sine of 30 degrees is half, correct? Substitute these values. So we get here square root 2 over 2 times cos of 30 degrees, which is square root 3 over 2, plus sine of 45 degrees, which is square root 2 over 2, times sine of 30 degrees, which is half. Add them. So we have 1 over 4 common and square root 6, and that is plus square root 2. Is that okay? So that becomes our answer. So in this particular case, we found that the value of cos of 15 degrees is what? Exact value is square root 6 plus square root 2 over 4. Is that clear to you?
Yeah.
So all this is required. When you do, keep your special triangles and all the formula handy to solve this value, and always write exact value. Shall I clear and move on to the next?
Yes.
Okay, so share the next question, please.
Example D, determine a formula for sine x over 2.
How will you do this? So sine x over 2. So if you know sine 2x, you can find sine x over 2, correct? Also, we could use there are a couple of ways to go about. We could also use cos 2 theta formula. You remember cos 2 theta formula? It was 1 minus 2 sine square theta, correct?
Mhm.
So from here also, I can rearrange and write 2 sine square theta is equal to what? Is 1 minus cos 2 theta, correct? Interchange the positions. Then we have sine square theta equals to 1 minus cos 2 theta divided by 2, correct? We can now do square root. So we get sine theta equals to plus minus square root of 1 minus cos 2 theta over 2, correct? Now the trick part here is you want x by 2. So if I replace theta with x by 2, then what happens? Let me write theta equals to x by 2. In that case, what is 2 theta equals to? X, correct? So I have sine of x by 2 equals to plus minus square root of 1 minus cos x over 2. So we have this formula as plus and minus. So depending on the angle, well, if x by 2 happens to be an angle which is kind of more than 180 degrees and less than 360, we'll take negative sign. Otherwise, we'll take positive because we know sine is positive between 0 to 360 degrees or 0 to pi, correct? So accordingly, you select the sign. So you can add these formulas into your list. So remember one more, which is determine the formula of cos x by 2. Similar calculation we can do for cos x by 2, right? So can I quickly do it? So we know cos 2 theta is equals to 2 cos square theta minus 1. Bring them together. We get 2 cos square theta equals to cos 2 theta plus 1. So we have cos square theta equals to cos 2 theta plus 1 divided by 2. And definitely cos theta will be plus minus square root of cos 2 theta plus 1. I should write 1 plus cos 2 theta just to maintain that symmetry, right? And replacing theta by x by 2, I can say cos x by 2 equals to plus minus square root of 1 plus cos x over 2. I interchange the position just to maintain the same kind of thing, right? So we get cos of x by 2 equals to plus minus square root of 1 plus cos x by 2 square root. Is it okay?
Okay.
So it's a very interesting subject. Everything just flows as I'm doing. So you should actually practice all this, right? So can I clear the screen and let's move on? Okay, next question, please.
That's the end for this unit.
Oh, okay. So let's do the next unit.
Proving identities.
Identities means both sides are same, left and right side, correct? So very first example, can you please read the example?
Example A, prove that sine x plus 2 sine x equals sine 3x.
Sine 2x. Sine x plus sine 2x equals to 3x is
not an identity.
Not an identity, right? So we have to show that sine x plus sine 2x equals to sine 3x is not an identity. How will you do? We do it by exception rule, right? So what do we do is, if you find one angle, at least one angle, which is the value of x, if you put that value of x and left side is not equal to right side, so we have to show that left side is not equals to right hand side for some x. Is that okay? So choose any value of x. So the convenient value of x will be 30 degrees. So in that case, 2x will be 60 degrees and 3x will be 90 degrees, right? Substitute and see what you get. So left hand side will be what? Left hand side will be sine 30 degrees plus sine of 60 degrees, correct? How much it is? Calculate. And the right hand side will be sine of 90 degrees, which I know is 1. So check, left hand side is what? Sine 30 is, half, and 60 is square root 3 over 2. And definitely it is 1 plus square root 3, more than 1, correct? So they are not equal. So with an exception, we have found that this is not an identity, right? Is that clear to you? So we provide a counterexample, right? So with that, we prove that it is not an identity. Clear?
Yeah.
So any exception can work. Any exception, right? Okay. So we've done the first part. Can I erase this?
Mhm.
Tell me the next question. Please read it.
Example B, prove that cos pi over 2 plus x equals negative sine x.
How will you do it? So we have to show that cos of pi by 2 plus x is equals to negative sine x. How will you do it? Tell me, what is your approach?
Mm,
Correct? Expand using compound angle formula. What do you get? You get this as cos of pi by 2 times cos of x minus sine of pi by 2 times sine x, correct? Now, what is cos of pi by 2? See, very easy to find the pi by 2 values and 0 values from the unit circle itself, right? So if I have these points at unit distance from the origin, what are their coordinates? This is 1, 0, right? And this is 0, 1. This is minus 1, 0. And this is 0, minus 1, correct? So we know the x value is cos theta, correct? And the y value is sine theta, correct? In a unit circle. And therefore, pi by 2 means this, right? This is pi by 2, correct? So at pi by 2, cos value, x value is 0. So here we have 0 times cos x minus sine pi by 2 is 1. So 1 times sine x. Is that clear? So which is equals to minus sine x. So it's straight, simple proof. So we get left side equals to right hand side, and we have shown the identity. Clear?
I think I'm still confused. I need you to explain it again.
Okay. So cos of pi by 2 plus x can be expanded using the compound angle formula, which is cos A cos B minus sin A sin B, right? So you remember that? Cos A cos
How
B.
do you know which one to use?
There's only one formula.
Oh.
It is not double angle formula, right? So just put A as pi by 2 and B as x. So we get cos pi by 2 times cos x minus sin pi by 2 sin x. Cos pi by 2 is 0 and sin pi by 2 is 1. So we get 0 minus sin x as shown here, correct?
Mhm.
That's how you'll do it. So start with left hand side and you get the right hand side.
Okay.
Perfect. So let's move on. Take the next question.
Example C, prove that cos x minus y over cos x plus y equals 1 plus tan x tan y over 1 minus tan x tan y.
Looks scary, but not so difficult, right? Expand. What is cos x minus y? Tell me. Plus, correct? That is cos x minus y, right?
Yeah.
And we have to divide this by cos x plus y. What is cos x plus y? Minus.
Yeah.
Sin x sin y, correct? Simple. We have, this is our left hand side, right?
Yeah.
Very simple strategy. You want tan. How do you get tan? You get tan by writing sine over cos. Correct? You actually get tan by writing. So how do you get tan? You get tan by writing sine over cos. So what we can do is we can divide both all the terms by sin x sin y, or cos x cos y. We should divide by cos x cos y, right? So divide each term by cos x cos y, right? So I left the space on purpose so that I can show you without rewriting it all over again. So if I divide everything by cos x cos y, what do I get? What do I get? This cancels, right? So I get 1 plus sin x over cos x is tan x. Sin y over cos y is tan y. See how simple it is? How simple it is. Just 2 steps. Get the idea? Tan is sine over cos. So divide by cos terms, right? Which are cos x, cos y in this case. So the first term becomes 1 in both the cases, and the second term is the product of tans. In between, we have plus in the numerator and minus in the denominator. That's what we need, correct? So
Yeah.
that is how we are going to do it. Done?
So
yeah.
for the left side, when it's cos y over cos x cos y, both terms get canceled out, right? Cos y and cos x.
Yeah.
That's why we have the 1.
Yeah.
And then we get the tan x because it's sine over cos.
Correct.
And then tan y is sine y over cos.
So 1 plus tan x tan y, 1 minus sin x tan x. Tan y.
Yeah.
Yes. So let me erase and read the next question, please.
Prove that tan 2x minus 2 tan 2x sine squared x equals sine 2x.
Yeah. So that may take a bit longer, but let's try to do it. So we have tan 2x as a common term. That gives us some idea, right? So we do have here, let's rewrite this question. So we have tan 2x minus 2 tan 2x times sine squared x. This is our left hand side, correct? So in identities, you should begin with a more complicated side and get the other side. Is that clear to you?
Okay.
So tan 2x is common. So I'll take tan 2x as common. Let's try this. And we have 1 minus 2 sine square x. Is that okay?
Where did that one come from?
Well, I took tan 2x common. So this tan 2x is common, right?
Mm-hmm.
So if you factor this out, we get 1 from here and 2 sine square x. Is that clear now?
Oh, yeah. Okay.
So now you remember what is 1 minus 2 sine square x? Tell me.
I don't remember.
Cos 2x.
Okay.
You remember cos 2x formula? 3 formulae were there, right? So one of them was 1 minus 2 sine square x, correct? So we'll replace 1 minus 2 sine square x by cos 2x. And now we are going to write tan 2x as ratio of sine 2x over cos 2x. What do we get?
Oh, then they cancel out and you're left with the right side.
Easy, right? But it's kind of tricky. Now you have to take, so I did not expand tan 2x and get into all that complex thing, right? I simplified it, just factor it out. And 1 minus 2 sine square x is an identity, which you have already done. So we use that and then wrote tan as sine and cosine ratio, canceled cos 2x, got the answer. Perfect.
So it's always better when you're proving identities to simplify the more complicated side?
Yes, of course.
Yeah.
Complicating the simple side is very difficult process. Simplify, correct. So next question, please.
I think that is all.
That is all. So have a look at the beautiful sheet which your teacher provided with the formulas. Okay, so we've done all that, right? Perfect. I think with this, you've done a great deal of work. And can you summarize today's learnings? I can
Yeah.
also pick up some questions if you want.
Yeah, that would be good too, actually.
Okay, so you can stop sharing this. And yep. And let me just share the screen and we have some questions. I'll take simple ones. I like you to do. Okay, one. So these are all based on the compound angle formula which you have just done. The very first one is simplify. We have sine 6u cos minus 2u minus cos 6u sine 2u. What is this equal to? So whenever you have this, in these brackets have vanished, but does it make clear? Is that clear to you? Of course, there should be a bracket here, right? What is this equal to? Tell me. Sine A cos B minus cos A sine B is sine A minus B, right?
Yeah.
So we'll write this as equals to sine of A 6u minus of minus 2u. Do you see that? So it'd be sine of 6u plus 2u. So it is sine of 8u. So that is slightly different because we have taken the angles or the arguments as negative. So that could be the case at times. Is that clear to you?
Yeah.
Right. So that's interesting. Let's move on and take the next one. Okay. I think I have to stop this and then go to the next one. Yes. So we have the next one now. Can you answer this question? Again, application of formula. So whenever you have this, it means it should be treated in a bracket. Is that clear to you?
Yeah.
So can you tell me tan minus 3 theta plus tan minus 2 theta over 1 minus tan minus 3 theta, tan minus 2 theta should be what?
So you're using the tan A plus tan B.
Yes, yes. Where A and B is minus 2 theta, and we know this is tan A plus B, right? So just plus them, right?
Yeah.
Plus minus 2 theta, right? So what do we get? This is equals to tan of minus 5 theta. Is it okay? Or minus tan 5 theta, because tan is an odd function, correct?
Right. Sine and tan are odd functions. Cos is even.
You are right. So that is how you will be doing it. So now the next question. Okay. So let me clear the screen. Correct. Again, the same thing, sine A cos B plus cos A sine B. You can easily do it. No, not a problem, correct?
Yeah.
So,
similar to question 1.
Similar to question 1. So now you know this is a very easy exercise. So you can easily do such questions, correct? Perfect. So let me just share more on similar kinds. So you are gaining confidence, correct?
Yeah, a little bit.
Okay, so I'll share more questions with you, but this time it'll be slightly more tricky. So let me just so you can see a couple of questions, correct?
Yeah.
So we have two types of questions on this page. The first one is write each sum or difference as a product with positive arguments. Is that okay? So we are arguments means the angle, 2 theta, 3 theta, all those things, right? So first one is sine of 4 degrees minus sine of 348 degrees. How can you write this as sum or a difference? Write each sum or a difference as a product with positive arguments. How will you do this?
So are you using compound angles here?
Yes, we are.
Okay. Is it just sine A minus sine B?
Okay, so we have two angles, which is 4 degrees and 348 degrees. So can you make a combination which becomes like something minus and something plus will give you the two angles? That's the key to it. Oops, oh, what happened? You get the idea. So we do have another way of working on this, and that is, you remember that sine A plus B, if we have a sine A plus B plus sine A sine B, what do you get? So let me show you. In general first, then we'll answer the question, right? What is sine A plus B plus sine A minus B? So the last two terms cancel away. So we get 2 times sine A cos B. Similarly, what is sine A plus B minus sine A minus B?
You get sine A 2 cos B.
2 cos minus. So when you minus, the first two terms cancel. The other, the first terms cancel, the other double up, right? Do you see that? A plus B and A minus B. So this is 2 times cos A sine B, right?
Oh, okay.
So we can write sum to product and difference to product. So sum to product formula, we call them. Do you understand? So we're talking about sum to product. Is that clear to you?
Yes.
So we are given here kind of a sum, because negative is also a sum. We have to write this as a product. So basically we are going to use this particular formula. So it is equals to 2 times cos A sine B. However, you have to find what is A plus B and what is A minus B. The best way to find is what? So midway between them, right? So if you have two terms, this is 348 is written as A plus B and A minus B is 4. So if I add them up and divide by 2, what do I get? Or if I say 340 add them and divide by 2, what do you get?
Adding 4 degrees and 348.
Yeah.
352.
Divide by 2.
176.
Okay. So if I have to get only 4 and if I have to get 348, what should be my two angles? If I do 340, if you subtract, see, think like this. I'll give you an easy way later, but first we have to, A plus B is equal to 348. And A minus B is equal to 4. Is it okay? So if you add them up, then you get 2A as equals to add them up, you get 352, right? So A is 352 divided by 2. What is that?
176.
And B should be how much? B should be 348 minus 176. How much do you get?
172.
So the two numbers A and B are 172 and 176, correct? Which I was trying to show you here. Add them, divide by 2 to get your number. Do you see that one of them? So we get 176 and 178. So now let me erase all this. You understood the concept, correct? And let me go to, okay, let's, okay, let me just do it. So we could write this as sine 4 as sine of, what did we get those numbers? 176, right? Minus 172 minus sine of 176 plus 172. Is that clear to you? All are in degrees. So when you do sine A plus B minus sine A minus B, what do you get? You get 2 times cos A sine B, correct? So that becomes, the question is write each sum or difference as a product with positive arguments. So that becomes a product of the two trigonometric functions. You get the idea?
Yeah.
That is how you are going to do these questions.
Okay.
So I'll share this video with you. So you have to do rest of the questions using this, and clearly I have those two numbers, right? So you say x plus y divided by 2 gives me one number, correct? And the other number is x minus y divided by 2, the other number. Or you could do plus and minus. So that is your a value. This is your b value. Is that okay? And then it's easy to do. And this is called converting from the sum or difference to product form. Is that clear to you?
Yeah.
Similarly, we could do this for angles given in radians also, correct? So here, if I have to find the two angles, what will I do? I'll do 11 pi by 2 plus pi by 12 it is, right? Plus pi by 12 divided by 2 as the value of a, correct? So which is 11 plus 1 is 12. And we have 12 times 2 here. So it is half. Do you see that? Half pi, of course. So a is half pi. Correct?
And then to find b, it's the same thing, just minus.
Yeah. So find b. So when you do minus, 11 minus 1 is 10, right? So we get 10 pi by 12 times 2. Is it okay? So we get what? So that is what we get, right? So you could write this as 5 pi by 12, correct? So use those values and get your answer. Is that clear to you? Minus 2, keep it separate. Is that clear? Both are sine, both are, so you could do like this. Both are different angles, correct? So you have to use sum and difference formulas. So that becomes another very important question for you to do. Is that clear?
Yeah. So then if it was the same thing but cos, would you do the same thing?
Yes. For example, this question again. So you have to use now cos A minus B formula, but you have to find what cos A and cos B is, right? Okay, so you have to use cos A minus B formula. I mean, cos A minus B, right? To get this term, correct? So, I mean, when you combine that, so cos A, cos B, you get. I mean, this is your first term, right? Cos A plus B and cos A minus B, correct? So then only you get. So this is basically expansion of cos A plus B. And then because this is negative, and therefore, I mean, you have to add them up. So therefore, you have to do minus. Is that okay? So when you do minus, then those two terms become negative positive, and what you get here is negative of this. Slightly tricky, but you have to do and get the answer. Is that clear to you?
So why are we doing minus instead of plus?
No, because the formula is that, right? So you get the idea. I'll just show you on a bigger screen. Let's say, okay, annotate with, I want to, I want this to be next question. You want to do the cosine one, right?
Yeah, this one.
This one. Let me derive the formula first, so that becomes easier for you to understand. So where is the annotation gone? Yes. Okay. So what is cos A plus B equals to? Correct?
Yeah.
Cos of A minus B. Now, if I do, because I need that plus in between, right? We need that plus cos thing plus sine thing, right? So I have to add them up, correct? So if I add them up, what do I get? Two times cos A cos B. In this case, we don't get minus. 2 times cos A cos B. Is that clear to you?
Yeah.
So now I have to write these terms as A plus B and A minus B. And how do I get them? I will get the A as equal to 9 pi by 12 plus pi by 12 divided by 2. Is it okay? 9
Yeah.
plus 1 is 10. So 10 pi by 24. Is it clear to you? Let me write that. And B will be 9 pi by 12 minus pi by 12 over 2, right? Which is 8 pi by 24, right? Let's not reduce. So those are your two values, A and B, right? So the answer will be, I could write this 19 as this, correct? And this as this form. So my answer will be equal to 2 times cos of A, which is 10 pi by 12, 24, I mean, and cos of 8 pi by 24. Do you understand?
Mhm.
That is your answer. You can always simplify them and write in lowest terms, but that is basic. This is a very interesting question, which now you should try. Is that clear to you?
Yeah, and then when you were simplifying, like when you were adding it, the signs got canceled out.
Yeah. Signs got cancelled.
Mhm.
But if I would have a minus sign here, then I have to subtract. Then I get minus 2 sine A sine B. You get the idea?
Yeah.
So that is what I was saying. If there is negative here, I mean, if there is negative here, we'll end up with minus 2 sine A sine B. You understand?
Yeah, and the cos gets canceled.
Yeah, but minus, that is what I was talking about. So I think we can end our class here. I hope you understand this is extended application for you. So with that, we'll end the class. Okay?
Okay.
Yes. Can you summarize today's learnings?
Yeah, today we learned how to find double angle formulas using compound angle formulas. And then we also learned how to use compound angle formulas and double angle formulas when proving trigonometric identities.
Correct. Perfect then. All the best, and we'll continue from here next time. Thank you. All the best.
Thank you. Bye, sir.